So this video is the continuation of the previous two videos that I made on trigonometry of grade 12. Okay, so we're going to look at 5.3 as we continue with this series. So 5.3 says given sine 36 degrees is equals to square root of 1 minus p squared. Without using a calculator, determine each of the following in terms of p. 5.3.1 tan of 36 degrees. Okay, the first thing that you want to do here is to draw a diagram. So as you can see from this, we have angle 36, sine of 36 degrees. So the angle that you're going to look at here is angle 36. That is going to be our reference. So I'm just going to quickly draw that. So this is our diagram, and we have, okay, let me draw it properly. And then we have angle 6. So 36, angle 36 will be in the first quadrant. All right, so we have 36 degrees here. Okay, so now we need to find whether what is our opposite angle, or what is our opposite side, what is our adjacent side, and what is our hypotenuse. So we know that sine 36 degrees is equals to square root of 1 minus p squared. But we know that we're just going to divide this with 1 because we want to have two sides represented by that. So we know that sine is opposite over hypotenuse. So meaning in this case, the opposite side is root of 1 minus p. So therefore hypotenuse will be 1. So I'm just going to write that in our diagram. So hypotenuse is 1, and then the opposite side will be square root of 1 minus p squared. So we need to find the value of x in this case, because this will be our y, and then this will be our r. All right, so I'm just going to use Pythagoras quickly here. So Pythagoras, if we're looking for x, is going to be x squared minus r squared minus y squared. So the value of r is 1, our hypotenuse squared, minus y, which is 1, square root of 1 minus p squared. And then you square everything. So 1 squared is 1, and then square root, when you square root, the square root will be cancelled, and then you're left with 1 minus p squared, because you take away the square root, so you're left with what is inside the square root. So in this case, 1 minus 1, you have 0, and then negative p, and p will give you positive p squared. So 1 minus 1 is 0, and then negative and positive. Negative and negative p squared will give you positive p squared. So we're looking for x. So the x will be plus or minus p squared. But as you can see that our diagram is in the first quadrant, so x must be positive. So in this case, we have positive p. So we have positive p as the value of x. So we can just write it down there. So I'm just going to substitute this in our diagram, that x is the same as p. So then we can now continue to answer the questions now. So the first one, 5.3.1, it says tan 36 degrees. So tan is opposite over adjacent. So opposite is root 1 minus p squared, and then adjacent is p. So this will be the answer for 5.3.1. And then 5.3.2, it says cos of 108 decrease. So 108 decrease will be 1 cos of 90. I believe if you say 90 plus 36, okay, let me see. No, this will not give us this will not give us this. So let me just subtract this from 180. So I'm gonna say cos of 180 degrees minus let's see, if we say 180 minus 36, it doesn't give us 108. So let's see, 236, 108. So if you subtract 72 degrees, that is when you get 108. So 108, this part here, this part is the same as what is inside the bracket, because 180 minus 72 will give you 108. Okay, so we're just going to use the reduction method from there. So when you say 180 minus 72, but we know that this will be the same as this is in a second quadrant, so cos is negative, so it's going to be negative cos of 72. So if you use your diagram, normally we say that this, what I'm referring to here, is when you use the diagram here, like we know that this is 90 degrees minus theta, and then this is 180 minus theta, and then 180 plus theta, and then 360 minus theta. Or this one you can also put here, that is the same as 90 plus theta as well. Yeah, so that is the information there. So but 180 minus theta, so take 72 as our theta. So when you say 180 minus theta, that is in a second quadrant. This is this area here. So we don't have cos is, if you use cast diagram, that cos is negative in a second quadrant. So that is why we have negative before cos, and then we say our theta in this case will be 72. All right, so that is the answer for that, but it's not there. We still need to continue with answering the question. So negative cos of 72, but we don't have 72 in our diagram, but we know that 72 is twice 36, right? So we're gonna just write that is a double angle, so we can reduce that 72 by saying cos, and then we say 72 can be written as 2 times 36. So it's the same as 2 times 36. So in this case, we have a double angle. So double angle of cos, you can reduce it to anything that you want, but in this case, you have 3 angle formulas that you can use for double angle of cos. So this is the 3 equations. These are the 3 equations that you can use. So I'm gonna just take the last one, which is in this case I will use this, which is cos 2 cos 2, and then instead of alpha I'm gonna say 36 because that is our angle, decrease, and minus 1. All right, so you say 2, and then for cos you substitute what is cos according to our angle. That will be adjacent, which is P, over hypotenuse, which is 1, and then you square that because that is cos squared, and then minus 1. So this is the same as 2p squared, because p over 1 is the same as p, and then when you square that, that is p squared, and then minus 2p squared minus 1. That is the answer for 5.3.2.